1.6 on inverse functions. Please listen carefully. First of all, you need to recall what a function. I gave you guys this example when we first started talking about functions a while ago. Do you recall this? You actually had a situation set up just like this. I gave you guys some side lengths, and we mapped them onto areas of squares. So if a square has a side length of 3, you square it, you get an area of 9. If you have a side length of 5, you square it, you get 25. If you have a side length of 7, you get 49. So what we're going to do today is talk about how do we work backwards? What if you had the area of the square and you wanted to work backwards to figure out what's the side length of the square? What would you do? And this is an easy example. You guys know if you have the area to work backwards, all you do is take the square root. Not a big deal. So an inverse function is the function that would allow us to work backwards. In other words, if we have the areas of the square, how do we get the side lengths? Just like I just said. All right, so the domain of a function, that means the x values of the function, is the range of its inverse. So let's go back up to this example. The domain right here, this is the domain. This right here is the domain. This right here is the range. So if we are working backwards, in other words, we are starting with the areas, this now becomes the domain, and this is our answer, so we would call this our range. Just working backwards, so everything becomes the opposite. All right, so a function. In this case, the domain would be the side lengths, the range would be the areas. The inverse function, you're working backwards, so the domain is the area, the range is the side lengths. Denoted. This is how we denoted inverse. This right here, important notation. F of -1 of x, the inverse of f of x. I will probably call it the inverse of f of x. You need to know that that's how it looks. Functions and their inverses undo each other. We already talked about that. This right here is important also. If you take the function and you comp it with the inverse of the function, either way, if you start with f and you comp it with the inverse of the function, or if you start with the inverse and you comp it with the original function, you are always going to get what we call the identity function. You should always end up with x. So if you want to know if you found the inverse correctly, you would comp the two, and if you end up with x, that means you found your inverse correctly. I will ask you to do that maybe a couple of times, but not a lot. We're mostly going to focus on whether or not you can find the inverse. All right, an example, f of x is equal to x minus 2. So let's say that this right here is the domain, and the function we're using is minus 2. You take the x's and you subtract 2 from it. So if you have a 5 and you subtract 2 from it, you end up with 3. If you have 7, you subtract 2 from it, you end up with 5. So what would the inverse function be? How would you work backwards? In other words, if this was your domain, what would you do to come up with your new range? What would you do? You would add 2. So the inverse function is just to take your current domain, which are your x's, and add 2 to it. Now this is an easy example. It's nice linear, you're just adding and subtracting. They will get more complicated, and we'll practice those, obviously. So I want to show you guys, though, as I said before, if you take the original function and you comp it with its inverse, you will always get the identity function. You'll always get x. So I'm going to show you how this works. Remember, if you are doing f of something, in this case the inverse function, you always start with the inside function first. Well, the inside function is x plus 2. You guys practiced this a bunch in the last section. So I put x plus 2 here. So what we're doing is finding the value of the function when I replace x in the function with x plus 2. So remember my original function was x minus 2. So I have to replace that x with x plus 2. So I replaced it with x plus 2, but remember I still have to subtract 2 from it. The plus 2 and the minus 2 cancel out. It leaves me with x. And like I said, I'm not going to ask you guys to do this a ton, but I wanted to show you that you're going to end up with x. All right, and then remember it also works if you do it backwards. You take the inverse function, comp it with the original function, again you're going to end up with x. And I'm not going to walk you through that whole thing, but if you want to digest that a little bit, I keep doing that. Again, you're going to end up with x. All right. Here's another one. Find the inverse and verify that f of the inverse of x and the inverse of x equal the identity function. I'm mostly going to talk to you guys here about if f of x is equal to x divided by 10, how would you get rid of dividing x by 10? Multiply by x. Another easy example. So you would multiply by x. So the inverse function, f of negative 1 of x is equal to 10 times x. We're multiplying here instead of dividing. Are you okay with that? You multiply. Now, if I comp them, f of the inverse of x, you do all the math, you're going to end up with x again. And like I said, I'm not going to walk you through that example, mostly because we're running out of time here too. But functions that have inverses are said to be one-to-one. You guys underline that, circle it or something. If a function has an inverse, if it is a function and it has an inverse, it's said to be one-to-one. Just a fancy name. The horizontal line test. I like this. This is going to tell you whether or not something has a function. If it doesn't pass the horizontal line test, it doesn't have an inverse. Horizontal line test works exactly the same as a vertical line test. It just means that if you can draw a horizontal line through it and have it only touch the graph in one place, it does have an inverse. So if a horizontal line intersects the graph at most once, then it has an inverse. So look at this graph right here. Is it a function?
Yes.
Yes, it is a function because every time I draw a vertical line, it crosses the graph in exactly one spot. Does it have an inverse?
No.
No, because if I draw the lines this way, it's going to touch in 1, 2 places. So we say, yes, it is a function, but it is not one-to-one. Why is it not one-to-one? Doesn't have an inverse. Does that make sense? So if it has both, if it's a function and it has an inverse, we call it one-to-one. All right, this one right here, it's a function and it's one-to-one because, first of all, it passes the vertical line test. Whenever I draw vertical lines, it's always going to touch the graph in exactly one spot. But if I draw them horizontally, get my drift here, you guys? When I draw it horizontally, it will also only touch the graph in exactly one place. Therefore, yes, it is a function, and yes, it has an inverse. All right, now, you guys didn't write this down earlier, and these things are pretty key. I actually think that we will stop right here.